this lecture. Good morning, all of you. In last lecture, we saw the load factor as well as the capacity factor, right? So the definition of the capacity factor, definition of the load factor, and in which sector or on which side that particularly capacity factor and load factor has been used. As we know, the capacity factor is related to the power plant. Okay, the running of the power plant during a particular period, and that is the ratio of actual output during the time period divided by output that could be produced or maximum output of that particular power plant, okay, during that particular time. As we also saw, the load factor, which is particularly related to the power consumption side. Okay, so load factor is average load demanded in that particular time period divided by peak load or the maximum load demanded at that particular time period. So similar to this one, we are going to see the different power factors. Also, the capacity factor must be, the value of capacity factor must be the higher, so it will be more profitable to the particular power plant. The examples also we saw the calculations, how to calculate the power factor and all those things. Okay, those are easy one. Now we are going to see the next types of the factors. Okay, that another factor is reserve capacity. Okay, now reserve capacity, as name indicated, it is the reserve capacity. Means if we consider there is one power plant, okay, in that particular power plant, the maximum demand or the total capacity of that power plant is 100 megawatts, but the actual requirement or the requirement by the consumer is the 50 megawatts. So in that case, the remaining 50 megawatts is remained. Okay, that much of capacity of power plant is not used. So that particular capacity is also known as the reserve capacity. So we can define this reserve capacity as the difference between the total rated capacity of all the units in the grid network and the expected peak demand of the system. So we can also consider the reserve capacity. We can calculate by taking just a difference between load factor and capacity factor. So it will be approximated or approximately calculated by using this particular formula, whereas we should know what is the load factor and what is the capacity factor of the power plant. Where this particular formula we can use, that is reserve capacity is equal to load factor minus capacity factor, where normal values of the reserve capacity is usually maintained between or near about 20%. So 20% of that capacity is not used. Okay, it will used for the emergency purposes, or we can reserve that particular capacity of the power plant. Similarly, next factor is utility factor. Okay, so as the name indicated, we can define the utility factor by the ratio of maximum demand of the plant to the rated capacity of the plant. Okay, so we are going to take just a ratio of maximum demand, okay, and divided by the rated capacity of the power plant. Means this particular maximum demand is again depends upon how much the power required by the consumer. Okay, and we can calculate this maximum demand by taking the multiplication maximum load on the power plant into load factor. Okay, because as we know, the load factor we can define as maximum demand divided by maximum load. Similarly, we can find out the maximum demand by multiplying maximum load with the load factor. Okay, so this one is one of the example to calculate the load utility factor of the power plant. As the name indicated, it's a utilize how much power plant has been utilized. Okay, in the scale of 0 to 1. Again, this factor having the particular value between 0 to 1. Okay, as similar to the capacity factor. This is another example to how to calculate the capacity factor. Consider there is a rated capacity of the power plant is 200 megawatts, and the maximum load which is applied on the power plant is 100 megawatts, and the load factor is 80%. So in that case, we can calculate the utility factor by using this particular formula. So to calculate the maximum demand, we can calculate maximum demand by multiplying maximum load to the load factor. Okay, so that is the maximum demand, and after that we can use the utility factor formula to calculate the utility factor. The next factor related to the power plant is diversity factor. Okay, now in this particular case, we have to use or we have to consider the group of consumers. Okay, because as we saw, the power plant, whatever the power developed, it will be provided to the consumer. Now there are different types of the consumer. Okay, each consumer required for a specific maximum power. Okay, it is having specific demand. Now that the particular demand is also going to be changed with respect to time. Means during the daytime, the industries required more and more energy. But in that case, at the same time, the domestic consumers required less energy. So the maximum demand is again depends upon the type of consumer, type of customer. Okay, and by using that type or considering that particular customer, we have to find out the diversity factor. Now consider there are a group of consumers or the customers, each individual or each particular type of customer having different maximum load, okay, at that particular certain time. Now the maximum load of demand or maximum demand of the group individual most probably may not occur at the same time. Okay, each having the uh, different load curve, we can say, each having different maximum demand at the particular time period. Okay, so in that case, first of all, we have to find out the maximum demand of each and every consumer. Okay, so we have to find out the maximum demand of each and every consumer or the customer. Okay, we have to add or sum that particular all the maximum demands, maximum required demands. Okay, and then we have to divide it by the highest maximum demand among that particular group. So that will be your diversity factor of that particular power plant, because each power plant having different customer, different states of the group of the individual, which is required different, which is having different maximum demands or different demands. Okay, so in that case, the diversity factor we can define as uh, it is a ratio of the maximum summation of the maximum demands of each and every group divided by highest maximum demand among that particular group. Okay, so just consider there is one group of individuals which is having, or group of customers having different demands. Okay, so in that case, first of all, we have to select the maximum demand value of each and every individual and take a sum of those particular maximum demands. Okay, so that will be your numerator. Okay, so that will be considered as a x. Then select the highest maximum demand value among these particular group individuals or whatever the customers are there. So taking the highest amount of or the maximum demand value from that particular group. So whenever we take the ratio of x upon y, that is your diversity factor. Now what should be the value of diversity factor? Again, this diversity factor value lies between 0 to 1, right? So in that case, the highest or high diversity factor value is the desirable. Now, why? Because in that case, the low maximum demand of the power plant is given or it is given by the for the numbers of consumers. Okay, so in that case, highest diversity factor must be, or it is desirable for the power plant. In sorry, the value of diversity factor is greater than 1. It is not 0 to 1. It is always greater than 1, because as we know, the summation of this maximum demands of each and every group is always higher than the highest maximum demand. Okay, so that is the diversity factor. Another next factor is the availability factor of the power plant. Now it is defined as the plant operating factor. Okay, it is also known as the plant operating factor, and it is defined as the ratio of time period in which the plant was in operation to the total time period considered. Okay, so it is the availability factor, how much time that particular power plant is available or the particular power plant is developing the power. That is the availability factor. Now, you will say, generally the power plant will work during all that particular time period or during overall years, right? But there are some time periods are there in which that particular power plant is not working, like the stoppage time. Because of the failure of any component, sometimes we have to shut off the particular power plant. Okay, sometimes fuel is run out of the fuel. Okay, so in that case also we have to shut off the particular power plant. So we cannot say the power plant is working continuously. Sometimes we have to stop the power plant, or whatever the power consumed by the power plant, or the power plant is not producing any power. So in that case we can calculate or we can define the availability factor. So it is simply the time period for which the plant it is in the operation divided by total time interval. Now consider there is 1 year. Okay, for 1 year we are going to calculate the availability factor. Now for the one year we know the total time interval will be 360 days into 24 hours, right? Or the 365 days into 25 hours. That is the total time period, that is the denominator. And the time period for which the plant is in operation. Now in that case, we have to consider, or we have to reduce the we have to mention the actual running time of the power plant. The time for which power plant is producing the power and it is supplied to the power grid. So we have to reduce, or we have to subtract the standby time. We have to subtract the stoppage time, okay, from this particular total time interval. That will gives you the time period for which plant is in the operation. So whenever we take the ratio of these two time periods, it will called as the availability factor. Now the particular value of availability factor is lies between 0 to 1. Okay, so maximum when the value of availability factor is near to the one, that is the desirable, as we know, because it is the common sense, right? For maximum time period, if that particular power plant is running, it will gives you the more profit. Okay, and it will gives you the continuously gives you the power. So it is simply means that power availability in the plant is available for use or for the consumers. Okay, now the standby is not really working status. Okay, in that case the power has been produced by the power plant, but it is not used by the customer. That is known as a standby. Therefore the total availability time is sum of the running plus standby time. Okay, now if we consider any particular power plant which is ready to operate during one particular week but held as a standby, in that case the availability factor is 1, but the capacity factor is 0. Okay, because we are not using, it is running, but it is available for the use, but it is not used. Whatever the power generated by that particular power plant is not used. So in that case availability factor will be the 1, but capacity factor will be 0. And if you consider if that particular power plant is operate at half rated power for 1 month, in that case also the availability factor is 1, but capacity factor is 0.5. So you must know the difference between different factors. Okay, there may be a chance of getting what you call as it will be the very difficult to understand the difference between these different factors. Okay, must but you must know what is the availability factor. Availability factor is totally different than the capacity factor. Okay, and capacity factor again is totally different than the load factor. So the difference must be known. The next factor is demand factor. Now it is the ratio of maximum demand of the consumer divided by total connected load. Okay, or that connected load at that particular point. Total connected load at that particular point. So it is the ratio of maximum real power consumed by the system to the maximum real power that would be consumed if the entire load is connected in the system. Okay, so it is just a ratio of maximum demand of the consumer divided by the total connected load in that particular circuit. Now for consumer, the demand factor is the ratio of its maximum demand to the connected load, and for the generator, or we can say the supplied side, It is the ratio of maximum real power consumed by the system to the maximum real power that would be consumed if that all the load has been connected in that particular grid. The maximum demand is the maximum load which is consumed uses at any particular time. Connected load is the total rating of the various electrical equipments which are installed in the consumer premises. We have to add total rating of that all these particular devices. That will be your connected load. The actual maximum demand of the consumer is almost always less than his connected load, because as we know, all the appliances are not going to be work at the same time. Okay, so in that case, the actual maximum demand is always less than the total connected load. Okay, so that's why the demand factor is always having the value less than 1, and it will be in between 0 to 1. Okay, so that is the demand factor. Then plant use factor, as we know, it is similar to the capacity factor, but it is different. So plant use factor is different from capacity factor in that actual operating power is considered. So annual plant use factor is known as the annual power produced divided by plant capacity into hours of plant operation. That is your annual plant use factor. Okay, so this is a simple one. So these are the factors, 7 factors we saw. Those are very important whenever we considering or analyzing any particular power plant, because whether we want to install the power plant, whether that power plant is profitable or not, it is depends upon these particular factors. So if we whenever we going for analysis, you must know those particular all those factors. Okay, in that load factor is there, capacity factor is there, utility factor is there, diversity factor is there, availability factor is there, demand factor is there, and plant use factor is there. Okay, and for particular numerical point of view, these factors are also important. Okay, because you have to calculate all those different factors. Okay, it may be given for 2 marks or the for the 3 marks. You have to calculate each and every factor. Okay, and in this particularly in this in from this particular factors, the load factor and capacity factor, these are the most important. Okay, these are the basic factors, and those are mostly useful to analyze the economically analyze the particular power plant. Okay, so this is the summarized slide, which you can see the different definition of the different factors here. Okay, each and every factors has been defined. Each and every factor is different than the other one. Okay, capacity, as we saw, load factor, it is the ratio of average load demanded in that particular time period divided by peak load demanded at that particular power plant time period. Capacity factor is defined as, or it is the ratio of actual output during the time period, one particular time period, divided by output that could be produced, or maximum output produced can be produced by that particular power plant. That is your capacity factor. Utility factor is the ratio of maximum demand of the plant divided by rated capacity of the plant. That is utility factor. Diversity factor means it is the summation of maximum demands of each and every individual or customer divided by highest maximum demand among the group. Okay. Now this the availability factor is it is defined as time period for which the plant it is in operation divided by total time interval. That is availability factor. It will gives you the availability of the power plant. Demand factor is again ratio of maximum demand of the consumer divided by connected load, and plant use factor is considered or defined as annual produced power divided by plant capacity into hours of plant operation. So these are the different factors we saw of that particular power plant. Okay. Now in this all factors having the value between 0 to 1 is except the diversity factor. Diversity factor having always having value greater than 1. Okay, so that is the difference between all those factors. Okay, now all those factors has been again affected by some other factors or other inputs, we can say, or the other variables. Okay, So following are the different variables from which, because of which all those factors of the power plant design has been changed. First one, as we know, the location of the power plant. Okay, so whenever we go to design a power plant, the locations matter most, because it will show it will from which on location we have to consider how to transfer the power from this particular power plant to the consumer. Okay, mostly the consumer must be real near to the power plant, so the transportation of the power is very less. Transportation cost will be the less. Then the availability of water in the power plant, because as we know, in hydraulic power plant the water is itself a working fluid. So in that case we require large amount of water. Then in the case of thermal power plant, we require water. As we know, because in the thermal power plant, the working fluid is steam. Okay, or we can say indirectly it is the water. So in that case also we require a large amount of the water. The next we can say diesel power plant or the gas power plant. In that case also we require water to in the cooling towers, right, or in the condensers. So the availability of water is most important whenever we considering the power plant. So that's why you can see mostly those power plants, even it may be a thermal power plant or it may be a nuclear power plant, those are installed near to the coastal area. So the water will be available. Sometimes in the nuclear power plant, we are using the sea water. We first carry out some water treatment on the sea water, and then we use that particular water in the nuclear power plant. So availability of water is crucial one in the case of power plant. Then the availability of labor near to the power plant, it is obvious, because to for the running of the power plant we required some labor, and that is the important. As we know, the size of power plant is very large, or it is very huge. So in that case, the running of that particular smoothly running of the power plant is required. That we require the uh, sound labor. Then the land cost of the power plant, as we know, it will going to give affect the what we can say the capital investment of that particular power plant. Then the low operating cost must be there. Okay, as we know, because it will going to affect the profit in that particular power plant. Low maintenance cost, it will reduces if the maintenance cost is low, it will reduces the total cost. Low cost of energy generation, as we know, if the cost of energy generation is very high, in that case the customer may be reduced. Okay, customer does not use that particular power. So in that case the cost of the energy generated by the power plant must be the low. Then a low capital cost. Now this total cost or whatever the capitals we require whenever we construct any particular power plant, if the capital cost is very low, in that case the risk taken by that particular supplier is also low. So capital cost must be the low. So these are the factors which are affecting on the power plant design whenever we going to install or planning to install particular power plant. Now the most important factor or the most important point in that particular chapter is load duration curve, or simply it is sometimes called as a load curve. Okay. Now the load curve means what? So as we already discussed, it is just a graph between time versus requirement, or the time versus demand. Okay. Now consider there is for one day, if you want to calculate, if you want to draw the load curve. Okay. Now consider there is a residential building or one particular house is there. It will require it is having different demands during the different time of the day. Okay, and for if one day if you want to calculate if you want to draw the load curve, in that case we are going to take time on the x-axis. Okay, just take a time on x-axis and demand on y-axis. Now the unit of that particular power may be a kilowatt hour or just kilowatt we can write down. Now whenever during that particular day, total day, consider this is the 0 hour 12 a.m. and it is 24 hours. So for these 24 hours, we are going to see how the demand will be fluctuated for that particular house. Okay. So now, generally, what will happen during the night or the early morning, the demand is very low. So in that case, the demand is remaining very low. At the morning time, demand will be increases. Okay, because all the peoples are starting to or uh, it is going for work. So in that case, it will require higher energy for the geysers or energy for the other appliances. It will require. So in that case, the requirement or the demand will be increases. Okay, for the morning session up to we can say the 10 to 11 or 11 to 12 p.m. After the 12 p.m., this demand will again going to be decreases because in afternoon there will be the energy consumed by the consumer, particularly in residential buildings, are very less. So in that case, the demand will be decreases. So it will be remain decreases up to evening. Okay, and from evening means after the 6 p.m. or after the 5:30 p.m. Again the energy demand will be increases. Now it will be increased due to the lighting load. Lightning load will be there, and because of the cooking and other appliances, the demand for the electricity has been increased. Okay, and this demand will be again decreases during the night time. Okay, so these particular graph, this is the demand graph where we can say the demand load curve on that particular uh, from that particular consumer. Okay, now this particular graph or this particular diagram is called as a it is called as a load duration curve or simply a load curve. Now, we can classify it or we can write down the different types of the load curve. Depends upon the time period. Okay, how much time we are taking. Okay, we can draw the load duration curve for 1 day. We can draw it for 1 week. We can draw it for 1 month, 6 months, or we can say it for 1 year. Okay, so for the different duration of the time, we can draw the particular load curve, and this is known as the load duration curve, or simply it is the load curve. And this is the most important because the different numericals will be depends upon this load curve. Okay, there will be a numericals, and we are going to see those numericals in the in coming lectures. So the fundamental difficulty with balancing the supply and with the demands of the electricity derives from the physical nature of the electricity and the fact that it is currently not commercially viable to store it on the sufficient scale. Okay, we cannot store the particular electricity, right? So in that case, we require this draw this particular load curve. In this regard, electricity is a unique commodity in that the rate of its production must be balanced, the rate of which it is consumed, or how much amount of electricity will be generated, all electricity must be consumed by the customer. Okay, that is the main regard for the condition we have to follow. So why we use those load curves? Okay, the demand for electricity. What is the demand of electricity? If you want to considering the variation of the demand during the day, during one particular day, or during particular week, or the season. If you want to understand that demand variation, we have to draw the load curve. Okay, so as demand for the electricity is not constant throughout the day, it is not constant throughout the year or throughout the season. It is varying, right? Or the fluctuating, continuously fluctuating. So first we have to study how that variation happen, how the demand has been fluctuating during a day, during a week, during a season, etc. So if you draw the load curve, we will get the idea. Okay. So we will get the idea, and based upon that, we can generate the particular power or based upon whatever the demand or the demand fluctuation or the variation with respect to that we can carry out the or we can produce or we can generate the electricity. Okay, or we can generate the power. So again, this is variation happen in daily. It may be a work weekly, it may be a seasonal, it may be a random variation, or it may be a long term growth. Okay, daily variation, it is because of the different appliances, uses of the different appliances, because during the morning time and during the evening time, because of the lightning loads, cooking, heating, etc. loads are there, so high energy requirement during that particular daytime, during the evening time or the morning time. Weekly variation, it is because the different during the different days require different demands are there. Okay, during the weekend, the demand for the electricity or the consumption of the electricity will be reduced. So that will be the variation, weekly variation. Seasonal variation in different months of the year often reflects the different climate conditions, different environmental conditions. So in that case, heating or air conditioning system will be required. So in that case, that will be cause the variation, seasonal variation. Sometimes that variation will be the random variation caused by the unexpected factors such as the system failure, sudden weather change, etc. And the last reason, that is the long-term growth. As we know, the demand for the electricity has been increases. Demand for the power has been increases, right? So that long-term growth also we have to consider. So these are the reasons because of which the demand from the consumer time has been varying with respect to time. Okay, and by using that load curve, we can use this particular variation, we can anticipate this particular variation, and based upon that we can generate the electricity. Okay, so that is the basics of load duration curve, and these are the reasons, that's why this load duration or the variation of the demand has been happened. Okay, now in the next lecture we are going to see the load profile, what is the load curve, what is the load duration curve. Okay, what are the different types of the load duration curve. Okay, and the different numericals that depends upon the load curve. Okay, so we will stop here. If anybody having question, you can ask now.